Our next topic in National 5 Maths then are trig rules. So the trig rules we're going to have a look at. So we're going to have a look at area of a triangle, we're going to have a look at the sine rule, we're going to have a look at cosine rule. Now all of these formulas are given in your formula list, and if you like using the formulas, you're going to pick up some easy marks with these ones. Okay, the first one then is area of a triangle. So area of a triangle is half AB sine C. It's given in your formula list, and I'm just going to explain where these different letters come from and what they mean. Okay, so your capital letters, like your capital letter here, C, are your angles. So capital letters are angles. So there's your A, B and C as your capitals, your angles. The small letters, A and B here, are sides. And side A is always opposite angle A, side B is opposite angle B, and side C is opposite angle C. Okay, so what this means when we've got the AB sine C, C is always going to be the angle in between the A and the B. So it doesn't really matter what they're called. They don't need to be called A, B and C. The sides could be called D, E and F. Be called anything at all. Be called Z, T and U. Makes no difference, but it needs to be two sides and the angle that's in between those two sides that you need to calculate the area of a triangle. Okay, looking at our first example then. We've got triangle ABC here. We've got one side's 25, one side's 20, and we've got an angle in between them is 30 degrees. So my area is a half AB sine C. Now this one does match up. There's side B, there's side A, there's angle C. It's going to be a half times 20 times 25 sine 30 degrees. From here, we'll just type it straight into our calculator. Okay, so a half times 20 times 25 sine 30, which is 125. Now it's an area we've calculated, so it's 125 centimetres squared. Okay, question 2. No letters in question 2. Okay, but you look here, there's my angle. I've got two sides and the included angle, or the angle in between. So area of a triangle, half AB sine C. So my area is a half. Doesn't matter what order I do the 12 and 7 in, they do the exact same thing anyway. So half times 12 times 7 times sine 70. Type it into my calculator, just exactly as it is there. Half times 12 times 7 sine 70, which is 39.46, 2 decimal places, 47, and remember our units, it's an area, so it must be centimetres squared. Number 3, here we've got the length of two sides and we've got two angles in our triangle. We still want to find the area. To find the area using my formula, I need this angle here. So this is the angle I need. Because that is my included angle between the two sides. So how do I get that angle? Angles in a triangle add up to 180. So add them together, take it away from 180, and that will give me 37 degrees. So that is the angle I want to use. Then I can use two sides and my included angle. Area of a triangle is half AB sine C. Half times 14 times 17.3 sine 37. Half times 14 times 17.3 sine 37, 72.88 centimetres squared. Okay, question 4. The area of the following triangle is 87 centimetres squared. Find the size of angle BAC. Angle BAC is this one here. I'm going to call it X, which is good because there's my two sides, there's my included angle. So area of a triangle is half AB sine C. We're going to fill in everything we know. As long as there's only one thing we don't know, we can work this out. So I know the area. The area is 87. That's equal to a half times 14.2 times 15 sine, and I've called that angle X now. Let's see if we can go from here. So that gives me 87 is equal to a half times 14.2 times 15 is 106.5 sine X. I'm going to rewrite that the other way. I'm just going to make my pen a bit thinner. So we get 106.5 sine X is equal to 87. Here I've got something times sine X. I'm solving the trig equation now because I'm finding the angle. So take this to the other side and divide by 106.5. Sine X is, no, didn't mean to write that, sorry. That gives me sine X. I just want X, the opposite of sine X. Check your calculator, is inverse sine. So to get X, I want to do inverse sine of 87 over 106.5. Shift sine fraction 87 over 106.5. Close my bracket. That gives me 54.8 degrees. Now, when you were solving a trig equation, I would always get you to look for your two answers. We only need our one answer here, and we're going to look for our acute angle unless told otherwise. Okay, so we don't need to bother with this part when we're finding this angle here. Number 5, in triangle CDE, so we've got triangle, it's called CDE. CD is 3 meters, DE is 8 meters, I've not drawn that very well, have I? The area of the triangle is 6 meters squared, and we want to calculate the obtuse angle CDE. So this is where we do need to consider our second solution. Okay, so area of a triangle is a half AB sine C. Put in everything we know. This is the angle we're trying to find. I'm going to call it X again. We know the area is 6. 6 is a half times 8 times 3 sine X. Half times 8 times 3 is 12. Writing it round the other way. I get 12 sine X is 6. So sine X is 6 over 12, or a half if you prefer. I get my answer in here by doing inverse sine, 6 over 12. That's my calculator, which is a half, which should give me 30 degrees. I have been asked for the obtuse angle. A reminder, an obtuse angle is greater than 90, but less than 180. So it needs to be bigger than 90, less than 180. So it's going to be in here. In here we do 180 minus. So to get my final answer, 180 minus 30, which would be 150 degrees. Okay, let's try a problem type question then. So paving stones are in the shape of a rhombus. The side of each rhombus is 40 centimetres long. The obtuse angle is 110 degrees. And what we asked, find the area of one paving stone. If I cut that down the middle then, down here, that gives me a triangle. I've got two sides. I've got the included angle, so I can find the area of the triangle. I can then double it to find the area of the rhombus. So area of a triangle, the half AB sine C. So half times 40 sine 110. So half times 40 times sine 110, which is 751 point, forgotten the end of it, 75 centimetres squared. That's the area of a triangle though. It's the area of the rhombus. Let's double that. So it is 1503.51. 1503.5. It will actually be 0.50 using that answer. Centimetres squared. That one's just because I used my unrounded answer when I typed it in to get straight from the calculator there. Okay, let's try some non-calculator examples then. Come on, page. Okay, I want to calculate the area of the triangle if sine B is 2/3. Okay, so we've taken whatever that angle is, we've done sine of whatever that angle is, and we've got 2/3. Okay, so we've dealt with the sine part. So area of a triangle is a half AB sine C. Got my two sides, and it's the included angle I've been given. That's great. That's going to be half times 10 times 12, and watch this bit carefully, it's not sine of 2/3, that whole part is 2/3, so we times that by 2/3. Dealing with the fractions then, a half of 10 is 5, so that's me dealt with those two. 2/3 of 12, 12 divided by 3 is 4, times 2 is 8, so that comes out as 5 times 8, which is 40 centimetres squared. Okay, let's try the last one. In triangle PQR, here's my triangle PQR. PQ is 4 centimetres, PR is √6, and sine of P is √3/2. So it's not the angle that's √3/2, it's sine of whatever that angle is √3/2. Okay, we want to leave our answer as a surd this time. We'll get what I'm writing here. So area of a triangle, it's half AB sine C, which is a half times 4 times √6 times √3/2. Okay, doing some tidying up then. A half of 4 is 2, divided by 2. They cancel each other out. So I'm left with √6 times √3. √6 times √3 is √18. √18 is the same as the square root of 9 times the square root of 2. Square root of 9 is 3. 3√2 centimetres squared. I'll leave you to practice some of these.